I welcome you all to today's class. Today we are going to study equations of motion. There are four basic equations of uniformly accelerated motion, and these are v is equal to u plus at, equation 1. The second one is s is equal to u plus v all over 2 times t, equation 2. The third one, s, is equal to ut plus half of at squared, equation 3. And the last one is v squared is equal to u squared plus 2as. We are going to derive each of these four equations of motion. Derivation of first equation. To derive this first equation of motion, we make use of the formula for linear acceleration, and that is a is equal to v minus u all over t, where a is acceleration, v is final velocity, u is initial velocity, and t is time. When we cross multiply this, we have v here minus u is equal to 8 times t, which is 80. So, adding u to both sides of the equation, we have v minus u plus u is equal to u plus 80. Minus u plus u will cancel out, leaving v is equal to u plus 80. And that is the first equation of motion. Now, second equation. Second equation, we'll have distance s is equal to average velocity times time. Average velocity times time. This means distance is equal to u plus v over 2. That is the average velocity of initial and final velocity times time. This gives us this equation 2. Then the third one. To derive the third equation, we shall make use of the first and second equations of motion. From the first one, we have v is equal to u plus 80. While the second one, s is equal to v plus u, or we step it the other way, is equal to u plus v all over 2 times t. So this distance s is equal to u here plus v. Instead of v, we put u plus 80 because that represents v. So we have u plus 80 all over these 2 times this other t. Now this means distance is equal to u plus u is 2u plus 80 here all over 2 times this t. Now expanding that, distance is equal to t times 2u. We have 2ut plus t times 80, we have at squared, all of them over 2 here. Now, it's the same thing as 2ut all over 2 plus at squared all over 2. These two will cancel itself out, leaving ut plus half of at squared, and that is the third equation of motion. To derive this last one, we'll make use of the first and second equation again. That is fourth equation now. From the first equation we have v is equal to u plus at. Making t time the subject, we have t is equal to v minus u all over a. And the second equation is distance is equal to v plus u all over 2 times time, meaning that this s is equal to v plus u there all over 2 times time, and time here is v minus u over a, which is v minus u all over a. So we multiply that out, we have v times v is v squared, v times minus u is minus v u, plus here u times v, we have vu, and then u times minus u is minus u squared all over 2 times a is 2a. So here minus u plus vu will cancel out, leaving distance is equal to v squared there minus uv all over 2a. So we cross multiply. When that is done, we cross multiply that, we now have v squared minus u squared is equal to 2a times s, becoming 2as. So to eliminate this minus u squared from the left to the right, then we'll add u squared to both sides of the equation. So this becomes v squared minus u squared plus u squared is equal to u squared plus 2as. Minus u squared plus this will cancel out. So this becomes v squared is equal to u squared plus 2as. And this is the fourth equation of motion. So next, we are going to solve problems using this equation. The first example there is that example 1. A car accelerates uniformly from rest. The car accelerates uniformly from rest. Uniformly from rest at 20 meters per second squared. Determine its velocity after 5 seconds. To solve this problem, it's important to identify the parameter given. And in solution 1, a car accelerates uniformly from rest. It means its initial velocity is 0. At 20 meters per second square, it means its acceleration is 20 meters per second square. Time spent, t, is 5 seconds. And so the velocity we are looking for is final velocity. So we make use of the first equation of motion, and that is v is equal to u plus at, because information concerning the three of them there. We have u 0, we have a 20, we have t 5. So we substitute. U is 0, A is 20, times time of 5. This will give us 100 meters per second. Therefore, our final velocity is